Ladies and gentlemen, have any of you ever thought what the love child between math, or learning algebra to be specific, and art could look like? Well, today we're going to see what that means exactly. But before we get started, I should say that I am a student in computer science, so.
Spare change. Spare change, ma'am. Squidward?
So any support or engagement while I make these videos would be very appreciated. I don't know, man. You may ask me, why am I learning math for a video right now? Like, what correlation could this possibly have with art at all? In linear algebra, we have these things called eigenvectors and eigenvalues. Without getting too deep into the details of the math behind it, they essentially give us the independent and orthogonal directions within a linear system. And the linear system can be represented as basically a series or a couple rows of like a linear equation, like you see on screen. And coincidentally, you know what else can be a linear system? A painting can also be a linear system, which is how we can use linear algebra on things like paintings, stocks, I guess. There's many different applications of this. These independent directions hold very important aspects of our paintings. It holds structure, it holds things like color, techniques, and very specific details, important details, which allow us to kind of find similarities between these different paintings. Like these two paintings right now on screen, they are different time periods from different time periods entirely, but they still show some similarities.
Algorithm and how it all works, right? So if we go over to algorithms.py, we have two different main functions. We have principal components and clustering. Our first function is basically giving us the algorithm of which I told you of how to find the directions, or otherwise known as the eigenvectors. This gives us the most important aspects of our paintings, right? This uses a algorithm called singular value decomposition. It's linear algebra stuff. I welcome you to go, search that up and how to actually know what it does and how it works exactly. It's pretty complex. But in clustering, we essentially, if you've ever taken algebra, I guess, and you know what a distance formula is, what that is, it's basically works using that. I'll show you the figure in a second. In data handling, very basic stuff. We just pre-process them, clean them, make sure they're all pretty standard and similar to each other, and just like try to make it as easy as possible to find similarities between each other. And of course, in main.py, we just bring this all together, running them together. Voila. Yeah. Over here, here's the graphic I have. We see like images. Oops. Images 9 and 13 are very similar. 429, and the numbering is like pretty. It should be consistent. Like 0, 1, 2, 3, and 4, are from the same period, while 13 and 0 are very different periods and whatnot. So that's what that means. And if we go over here to look at the results, like I said before, image 4, I think, compared to image 12, very similar. You can see some similarities there from the algorithm. Overall, that's what the algorithm does and how it works. I hope you enjoyed the video and enjoyed a nice little lesson on how some math works and how we can use it on very different fields, like very opposing fields. Math and art, very opposing things. Like there's STEM and there's whatever, it doesn't really matter. I think it's cool. Hopefully you do too. See you.